Good morning, everybody. I'm Nigel Forrester. I'm with Concurrent Technologies. I'm the Technical Marketing Manager. And for those of you who don't know, Concurrent Technologies for nearly 35 years specializes in designing, manufacturing, and supporting Intel processor-based solutions for deeply embedded applications, along with some other accessories to go with it. So my topic today is big and bright security. And those of you who know me will already know that I like to try and engage a little bit. So you might think, well, what do I mean by big and bright security? Does it mean that everything is so good in the world that we don't need to worry about security on the one hand? Or does it mean perhaps on the other hand that there's so many different security issues that the world's about to end? Or is it somewhere in the middle? Okay, so trying to sort of stimulate things a little bit, but I am going to bound this by talking really about what security means for some of our embedded defense customers, which makes it a little bit easier to talk sensibly in a short period of time. So, if I look at what happens in my typical consumer use, if I take myself, I've been traveling for the last few days, I've got a laptop, I connect to various public Wi-Fi networks. I've been on all sorts of websites, of course, all legitimate to do things like book my travel, but I'm typically the only user of that machine. Whereas if you compare that to a typical embedded defense customer, it is somewhat different because most of the applications we see are in very tightly controlled, secure, closed environments. Many have no connectivity at all to the outside world. They typically are running a single task, although that perhaps has become less so as we've developed more server-based products that do some multitasking. And particularly in most of the deployed applications, many users have a hands-on part of that equipment. And that might not just be the actual end user, but it might be the people who service the equipment and maintain it. And so if I try and assume some sort of risk, so the blue triangles in this case are trying to show sort of maybe an idea of the amount of risk and where it's sort of controlled or where it comes from, in my experience, the embedded types of applications typically do have less risk. They come from different areas, which gives some challenges, but the risk is one area. What happens if that security is compromised? Obviously, the consequences might be significantly greater in an embedded space than they are in a consumer use. If my laptop gets some malware, I can just re-image it. It's not a big deal. If a missile control system gets compromised, that is an extremely big deal. Okay? So the good news is that the users of our embedded type of products can often leverage many of the things that have been developed in the consumer space. And I'm going to start by talking about some of those. And I'm doing that with using Windows as a starting point. Now, the reason I've chosen Windows other than Linux or VxWorks or QNX or any of the other operating systems that our customers use is it's very easy to see the development timeline, the features that are assigned to it, and so it makes it a very nice example. And you can see I've chosen a few arbitrary versions of Windows, and over time, there are many new features that have been delivered that are predominantly focused on security. And obviously the current solution being Windows 10, where there are particularly a number of new application type features or user type features that are very security related. And we'll talk about a couple of those in a minute. There's a couple of key takeaways from this slide, and we're going to come back to the timeline again in a minute. First of all, it sort of surprises me that we've been going for 25 years on this particular timeline. It's taken a hell of a long time to get to that level of security. So maybe that means that we didn't need to worry about security so much in the olden days. Maybe it means security is really difficult and it's taken a long time to get to the level we are today. But it does sort of give an indication of how slowly things tend to move, even in the fast-paced consumer world. And the thing I want to start talking about is the trusted platform module. So that's the thing that I've got in sort of highlighted a little bit. It was sort of first really utilized by the Windows 7 with TPM 1.2 and then TPM 2.0 is really a fundamental feature now of Windows 10. So that trusted platform module, what does it do? It's really a small tamper-resistant integrated circuit. I've got a picture on the right here showing a TPM fitted onto one of our processor boards. So it's not a particularly big device. And it's designed to give an independent store of some sensitive information and to be able to generate things like cryptographic keys. So it's not high-speed, doesn't have high-speed interface. It's a relatively low-cost device, and it's a relatively independent type device. And some of the things that you can do with a TPM, you can do what's sort of loosely termed a measured boot. So you can use the TPM to record a hash for things like a firmware image. And you can do that sequentially. So you can actually get a very nice measured boot. So for example, you could start right on the left here by measuring the hash of the BIOS and storing that. And then you can do the same for the OS bootloader and the OS kernel and the application. And then you can analyze those hashes remotely if you want to, using things like remote attestation to make sure that they're the correct images. Or you can do something a bit more sensible. Rather than just measuring them and then checking later, you can actually only boot your system if you have a right signed image. And that's effectively what things like Secure Boot do, is they actually check to make sure you have the signed operating system bootloader, which in turn then goes on to load that operating system. So the TPM can be thought of as adding a level of security there. There's a couple of other things that have been introduced recently that I'm just sort of mentioning because they're quite useful things that we can leverage. So Microsoft has introduced a feature called Credential Guard, and that's designed to stop what's called credential creep in these large organizations. So effectively, it does that by isolating, using virtualization, the login credentials from anything else, including the operating system kernel. So that's designed to stop you or somebody infecting maybe a relatively non-secure machine in a large organization with a piece of malware, getting hold of some more credentials and gradually building up so they then get to the really secure stuff. Another little simple thing is Intel have introduced recently is a thing called Boot Guard, and that's a hardware-based scheme that prevents boot block takeover, again, using the TPM. So lots of sort of things that can add up to a secure solution, or at least can aid a secure solution, particularly with regard to booting that device and getting going from starting point. Now, I also, in that timeline, I showed sort of TPM 1.2 and TPM 2.0. So the TPM device has had an update. It's actually been around for a few years now, and the TPMs are really controlled by the Trusted Computing Group. But the TPM 2.0 has really started to take off recently, and fundamentally it does two things. It gives you a better security level, so it supports a lot more sophisticated cryptographic algorithms. TPM 1.2 is quite simplistic there, and it also has improved things like, or simplified things like management. So it's now possible to actually make use of the TPM purely from an operating system point of view without doing lots of other things to make it work. So it's trying to make security easier from a consumer space. And the key takeaway here is that what we've seen in the embedded industry, where we've been supplying boards for quite a few years with TPM 1.2s, we've now, moving forward, only supplying new boards with TPM 2.0s, but we've also taken a step and looked at the boards that we've developed over the last few years and decided that actually we'll go back and we'll now offer those boards also with TPM 2.0. So we've done a little bit of engineering work to keep our current products up to the latest security standards. So if I go back to my timeline, this is all very well and good if you can use something on the right-hand side here, the sort of latest operating system or the most secure operating system. But what happens, as is the case in a lot of defense applications, where you can't? Typically, the defense industry is extremely risk-averse, very prone to reusing stuff if they can, and that's very true of applications operating systems. So we have many customers, as I'm sure many other people in this room can attest to, who have been building a piece of equipment for many years. They want a new processor board, but they actually want to run the same software on it that they ran 5, 10, 15, or longer. So it's probably no surprise to you or to me that we have quite a few of our customers who are still running applications on Windows XP. It's slightly more shocking that we have, and recently we had a very good example where one of our customers was running Windows NT. And actually came to us saying, well, we want a new processor board, but can you make it run Windows NT? Dating back to, I don't know, 15, 20 years ago. So what can we do to help those customers and still retain a degree of sanity and a degree of security? So first of all, one possible route is just to use a hypervisor. And this is quite a simple route where effectively the hypervisor can either run natively, you can get bare metal hypervisors, or you can actually run a hypervisor associated with an operating system. So Windows 10, for example, has the Microsoft Hyper-V built in, or Hyper-V capabilities built in. So it's possible to boot a board using that hypervisor and then run the legacy operating system and application in a virtual machine. So that gives you a degree of security because you're booting a known, trusted, and rigorously defined operating system image to start with, but you're then still running your application in a virtual machine. On the other side there's some concerns there about, particularly for real-time applications, well, is that going to have an impact on performance? So we've done a number of benchmarks recently. We did some benchmarking for a particular customer who was considering using a hypervisor, and in their particular case, using the hypervisor used about 10% of the computing resources. Now that was fine in their case, that probably wasn't an issue, but obviously that's very application specific, and it's very, it's difficult to give guidelines as to whether that's a good method or not. But at least it's one very easy solution, and it can be as simple as loading a hypervisor and then loading the existing application in a virtual machine, and off you go. Perhaps a better way is to look at security from a sort of holistic environment. So since 2012, we've been offering a package that we call Guardian Security, which is largely operating system and board agnostic. So it is a proprietary scheme that we've developed, which includes a number of different hardware, firmware, and software elements, which effectively tries to do all the sort of things that you can get with the off-the-shelf standard technologies, but do it from the context of a particular board. So there's really three key goals of Guardian. It's designed to prevent unauthorized use. So anybody who doesn't have authorized access to the equipment shouldn't be able to operate it. But not only that, we need to be able to make sure that even if you gain access to the equipment, that you can't gain access to the data. And that's whether you are an unauthorized person, or perhaps you do have access to the hardware, so you are sort of authorized to do something, maintain the equipment, for example, but you must not be able to get hold of that data. And very importantly, at the end of the day, you have to have a way of sanitizing that equipment. Because if it's being moved from a secure to a non-secure area, any sensitive data has to be sanitized. And one of the areas that we've done multiple improvements on many times is to improve the ways that we operate that sanitization scheme to make it more rigorous, to comply with various Department of Defense guidelines and so on, so that we can be certain that if you run a board through the sanitization process, that all of the information that is sensitive on there is either completely removed and the hardware is in some cases made inoperable, or that it's returned to the default factory configuration. And there's lots of bits to Guardian. I'm not going to go through this list in any detail, but as I said before, it consists of a lot of hardware, software, and firmware type things, which are proprietary to us. Now, there's quite a good argument as to say, well, if that's proprietary to us, does that mean it's not that good? We've not been tested by lots of external people. There's not people at Black Hat trying to break our security system. So yes, maybe that is a slight concern, and it means we don't necessarily able to tick the boxes to say that this is always certified to external levels. But on the other hand, it also means that there aren't people trying to break it. There's very few people who know about it. It's very tightly controlled. So actually, on the sort of swings and roundabouts scale, that's actually quite a benefit. The other thing that we've spent a lot of time and effort and is worth talking about is that as well, no, let's step back a bit. When we ship boards, we typically have we design the printed circuit board once. So we have one version of that product. So we can ship that in a completely non-secure configuration, and that's what we typically do by default. So if you're starting development, you'd probably want a board, as quickly as possible. We'll just ship you a standard board. We also ship exactly the same board, but with some of those changes at the production time, and having our own factory means we can easily implement that so that the board is shipped in a security configuration. And that means that as it arrives at the customer, they can be guaranteed that that board is what we say it is, and it's shipped with all of the right features to turn that into a secure product. What we then require is that each customer takes that board and they test it to make sure that when they load their application and they're running that in a real-life situation, that they know exactly how that works and they're happy that they've reached a defined base level configuration, and that anything that their customer or their operators can do to that product will not break the security. The last thing we require them to do is to enable the security lock on that product. Once they've enabled the security lock on that product, if something else happens to that board that they weren't expecting, then that board will be permanently locked. And we know our security solution is quite good because we've had several customers come to us, haven't tested the product properly before they've enabled the security lock, and then they've locked the board. And so that's an interesting scenario. And then the last stage is to be able to remove that board from service. So that's where we're talking about the standardization. So wrapping up, we've seen that, and this has been quite a turning point over the last 12 months, that a number of defense-related customers, particularly from the US, have come to us saying security is actually their number one concern, and they are prepared to give up a lot of that legacy applications. They're prepared to re-engineer stuff, but we must meet certain benchmarks. And that's the first time we've really seen that from the defense community. We've also seen that, no matter how closed your security environment, you still need to worry about security. It's not possible to have one thing that fits everybody, so you have to be really flexible. And my final point really is that nothing is 100% secure. There'll always be somebody who can try and break something. So at the end of the day, I think my conclusion is that there's big security concerns, but bright solutions out there. You go find them. That's what we're here to sort of solve those problems. So hopefully you may agree with that. If you don't, well, that's my opinion. And so I'll say thank you very much, and any questions?